Pat Deegan, man. Thanks so much. Thanks for coming on board, man. I really appreciate it. All the sound issues.
Yeah, what a mess. Well, nice to finally chat with you in person, Stewart. And ladies and gentlemen, welcome to sunny Montreal. The current local time is about 8:15 now, 8:30. Damn, it took us a while to set this up, but here we are. So I'm glad to be here.
Yeah, man. When I saw a video of you where you disassembled a Chinese pick and place machine, and you got open PNP to work on that. And as the Leonardo DiCaprio in Once Upon a Time in Hollywood, that meme where he's like, I was like, that's my man right there.
Nice. Yeah, that was kind of an adventure, because I was sitting on that thing for a super long time, and then I'm like, okay, I need to make use of this thing. So I crack it open, and I just went wild. I had this plan. I'm going to make it's going to be open PNP, because that's what I use, because that's what I want. And so I start this, and someone just commented like yesterday, maybe showing how it worked originally with the original software would have been cool, like informative. And I was like, yeah, no, you're totally right, because I didn't even know if it worked, and I'm there and I'm updating the firmware and everything, and it's like, okay, I'm going wild. And then you saw the video, it was an adventure. But it all worked out, and and then I get this other comment, and the guy says, because I made this joke in the video, and he's like, you would have been better off with the fidget spinners. And I was like, oh no. But so far, actually, the machine has performed pretty well. I've done a few little runs with it, and it's nice. It's an upgrade.
Nothing too complicated. You haven't done any. What's the greatest complexity of the board that you've done, and how many parts on it?
I guess, look, there's one, it was a tiny run. It was 5 boards. And so, okay, setup time is a pain in the ass. So what you do is you go, well, is it worth it? Is it worth it? Well, it wasn't worth setting everything up, but there were like 60 passives on there on each little board, and doing those by hand is not a great time. So what I did was, I have these reels of standard components, 0.1 caps and stuff like that. And so I just populated those. So it took, I think it was like 18 minutes to do the 5 boards. I mean, from A to Z, I'll start the machine and make sure everything's okay. And then it took me 3 hours to populate the components I didn't put on,
Oh, yeah.
Sadness. So that board would have been the most complex. I did this little IoT thing. I did a few boards. I even did a rep wrap type style, where I was doing a board for the machine on the machine. And so,
Oh, yeah. No, that draws me back to, I think, was it 2011, maybe 2012, when the rep wrap first came out. And at our local hackerspace, we were like, fuck it, we're going to build a rep wrap. And we set about building like the first version of rep wrap. It was actually it was a very informative thing to do. I really enjoyed that.
Well, that's the thing. There was this, it's not really true now, but there used to be this saying, Linux is only free if your time is worth nothing. and that was a good zing. But but the point is, I started this stuff. I was introduced to Linux when I was at university, and I was like, wait, what's this? And I got really interested. But back in the day, what a pain in the butt. Okay. Oh, you would like to connect to the internet. Okay, here's how a modem works.
Oh, yeah.
And so you would basically have to digest everything before you got anything done. So yeah, it was a time sink, but boy, did I learn. I mean, I went insane. And so, I have the little 3D printer, I have these things, and you end up tweaking them and building them, and you end up spending much more time than if you had just sent it off to someone, to do it. But we're not talking mass production here. We're talking about, I want to have it right now, and I want to have it when I want it, and I'm going to learn a ton of stuff just by playing around with it. So in the end, that time sink of building the P&P or the rep wrap or whatever.
Yeah.
I mean, you're someone else at the end of that journey. So.
It makes me think back to when because I grew up in South Africa, right? And back then we had this internet monopoly called, this telecommunications monopoly called Telkom, who charged by the minute for connection to the internet, right? Now, of course, my father, born in 1928, he was like, "What's this internet thing? No, you cannot have a modem, but you can have a 286." So we got an old 286, and I remember reading in these sort of like magazines about Linux. What's Linux? What's Linux? And I got used to the little penguin icon. And one time I was driving down a road and I saw something called Slackware on the side of one building. It was a bunch of nerds. Wow. Yeah. And it was a bunch of nerds with long hair. And I remember like passing there 3 or 4 times, and I walked in there and I was like, right, I'm going to get a Slackware, whatever a Slackware is. And I walked in.
I want to be in this club. I don't know why, but I'm really attracted to this. And this is what I'm going to be. Yeah.
So I walked in there with 20 Rand, which is about, I don't know, what would that be, like $1 or something, your money. And they gave me a cut CD. And I went home, and how I taught myself was how-tos, RFCs and how-tos.
That's it. You're reading the straight up RFC, and I mean it's dry stuff, right? But you're training to understand how to communicate technically while you're doing it. Side benefit, little Trojan, and you're learning a ton of stuff. Yeah. Oh, look, that time. I mean, shit. First of all, by the minute internet. I mean, a way to basically propagate freaker culture, okay? Screw you guys. So that's one thing, and the other is you've got this where was I? You've got this notion of for me it was GNU. I mean, just the name, this recursive.
Yes, that was cool.
I was like, wait a minute, this is interesting. Okay. And I was at a period where I was like, holy crap, they're going to shut this down for sure, man. And so I'm downloading and archiving. I'm the archive because I have this, 14K modem, and I can archive the world just to make sure it never goes away. But that turned me way on. And I mean, I had started playing with computers. Well, I don't know if we want to get into that, but
no, why not? I mean, come on.
Okay, the short version is this. Why do we do this? Why do I do this? When I was a kid, I wanted to build 2 things: a tricorder and a phaser. Okay. Of course. So it turns out I've built a ton of tricorders, in the end, because it's like sense and record and compute. I mean, that's basically IoT, right? But the point is, I wanted to build these things. And hardware, it turns out, was, I didn't have some Elmer, some ham radio dude to mentor me into this. Yeah. So I had Forrest Mims books from Radio Shack, and kind of go for it. Okay, all right. I turned on an LED. That's great. But then these concepts were just weird. I mean, I needed someone to tell me that ground had nothing to do with the ground. Where do you get a -9 volt battery? These concepts, which are, duh, but at the time when you're starting off, it's like, so I kind of moved away, and then people were getting computers, and my friends had these Commodore 64s and whatever, and they were playing all these games, and games, that looks really fun. I mean, I want some computer games, Dad. So he gets me a computer. All right, cool. I set this up, turn it on. It's a blue screen with a blinking cursor. Okay.
Fucking hell. My first encounter with that cursor was terrible.
No, but okay, there's a manual. I'll check the manual. And back in the day, there was an actual manual, and it was a thing, and you could look at it, and it was complete. And so 10, print hello, 20, go to 10. All right, a computer. So there I go, and I start coding this stuff up, and I want to make games because I didn't get the Commodore 64. No, I got a color computer, and so I'm going to make a game. And anyways, I guess that was the first time I learned that I was going to be a dealer more than a user, because I ended up working like crazy to get this game going. I think my best one was called Sunday Driver. It was like a top view car thing. I even got the joystick, the PS2 serial joystick thing.
Oh,
I actually I caught myself a few months ago working on a bug in that program. Okay, I was like, well, okay, because the object detection was basically color-based. I was placing them and not remembering where they were. So the car had to hit the thing and change the color of the road, but it only worked in the corners and whatever. So, but the point is, I make this game, and it was not great, but it was okay. And then I played, and then I was like, yeah, let's make something else. And so that's beginning of high school me. And then, well, adolescence and adolescent things kind of take over, and I move away. And then when I get to university, Linux. Okay, well, you have to install this, and then you realize, hey, I'm sitting here with this computer, and I've got the same OS and the same tools, SendMail and Apache and all this stuff that the ISPs have.
Big boys.
It's all here.
Yes.
And I can do anything with it. I could be an ISP. And so that drove me wild. I was like, wow, okay, we can play with this. And having to read the RFCs to get anything done, I was learning like mad. And I went into some cocoon mode, and I basically came out of it, and I was in IT. That's where I started going. I got a job in IT. Physics is cool, but I don't want to work for academia. I don't want to work for the military. I mean, not too much left. So IT it was.
And what was it that you were studying? Was it information technology, or like
No, it was physics.
Oh yeah.
I like how things work, and you cannot get much closer to how things work than physics.
Yeah.
So it was a joint honors. It was a math and physics, but it was physics.
Yeah.
And it was really sweet. And I'm still curious, although I kind of moved away because physics is in a funny situation now. It's like,
yeah.
Oh, here's a thing. This might exist. Let's check it out. Yeah, you have no reason to think it exists. Yes, but we can build a machine and see if it does. So, anyways, anyhow, I ended up doing IT for a long time, and it got really big. These clusters, these giant databases, these graph things, and blah blah, and it was getting huge and kind of dull. And when things get dull, like I always start these careers this way. I just kind of throw stuff out there. In IT, I was getting bored, so I'm gonna branch off. I'm working in this job, but I'm going to branch off, and I'm going to take contracts. And I start, I want to offer, there's this potential client, I want to offer two options, the Windows thing and the Linux thing. And it was an automation of a business and blah, blah, blah. But there was no way to handle phone calls, press 1 for English. So I end up doing this, I'll make it, whatever. I'll use a voice modem, and I'll make this program. So I make it, and I end up working like 2 months on this thing, and I never get the contract, but I finished the program. And, I've been infected by the GNU. And so I want to give back. So I put it online, and my father's like, "You're giving it away. Dad, you don't understand, man." Classic shit. So I put it online, and I kind of sneak it on one of the servers that from work, because I don't have a server for myself, and I just kind of put it somewhere in a corner and stick it on Fresh Meat, and it goes wild over the weekend. And I get back at work, and it's like, Pat, what's this? Oh shit. Anyways, so it was weird because it was popular, and there was a period of time when people would call to get their messages, and it was me saying, press 1 to hear your recordings and stuff like that.
What was the name of that program?
It was like VOCP, and I can't even remember if it was a backronym or what it stood for. The point is, this thing goes crazy, and well, crazy for
Yeah.
back in the day.
Yeah.
And I remember one day I did that because I was getting bored at work, and I get in there, and it was a snowy, crappy day, and I got in late, and and I checking my personal email, and there's this email from this guy. Hey, I saw your program, and it was pretty cool. Yeah, you want to come to California? Yes, I do. Let's do this. And so that led to an adventure. Now, fast forward, I don't know, 10 years or something, and I'm at the point where I'm in that similar stage, and I funded. It was like one of the first Kickstarters I ever saw. It was the Stump, or I can't remember what it was. It was a little AT-Tiny 85 or something like that on a USB key. And so I crowdfunded this thing, and forgot about it because it was so long. And then one day I just get this thing in the mail. I'm like, oh, yeah, that's pretty cool. And I start messing around with it, and same thing again. I start playing, and then okay, I've made a beautiful thing. Well, now what do I do? Well, it's nice. I've got this lighting system for my plants and whatever, and I can
wait, hang about. So okay, a DigiKey, this DigiStump. What was it?
No, it wasn't DigiKey. It was
DigiStump. You said.
Yeah, but that's not right. It was Digi something. Anyways, it was a little.
And did this inspire you to do something?
Well, I made something. Yeah, I started playing with that, and then I got these RGB LEDs, and I was like, hey, you know what? Well, how does a plant know that it's not, in a sunny, wonderful world? How does it know that it's not in Jamaica or something like that? Well, it's the curve of the light. It's blue, and then it's red, and then it's blue, and so I'm going to.
So it's an IoT thing, right? This device that came is like a sort of an IoT thing, like a small micro.
There's no connectivity. It was a USB key with an AT-Tiny 85 on it.
Oh, then you flash on software onto it, and then okay, and it's got some sensors, or else you can read information.
Man, this was it was an AT-Tiny on a USB key.
Okay.
That's it. But the point is, it got me playing, and so you make this stuff, and then it's like, well, that's cool, but what am I going to do with it? Well, someone else might make something with it, and so you start putting shit online, and then somebody says, that's really cool. But what I need is a little bit different. Can I give you money? Yes, please give me money to do this thing that I'm doing because I'm bored at work. And so, whoop, and then there was a transition into hardware. That's pretty much the story. And so I've yet to build the phaser, but
that's on its way. Okay, all right. So then you set up this. What's it? Psychogenic or Psychogenic?
Actually,
how did you come up with that name?
Pardon?
How did you come up with that name?
Well, it was a creation of the mind, right? Psyche and Genesis. So that was it. It turns out, if you look it up, it's some sort of weird disease. I'm terribly terribly bad at naming shit. I did this VXML whatever server thing for IVRs, and I had called it Vixen because it was VXML and it was cool, but the boss did not like it. This was in California. All these things, I'm always coming up with names that are pretty bad. Although the Neptune thing, I was happy with that. So it's a tuner and it's Neptune.
Come on, that was great with the whole
yeah Project Neptune. So yeah, anyways, Psychogenic, and I kind of started that. I think I registered the domain like when I was still at that job, and I was looking for contracts and whatever, and it just stayed on ice for a little while. And then when I came back from California, 2 years later or something, I was like, okay, it was fun, the cubes and the Nerf and all that stuff, but I don't want to do cubes anymore. I'm not doing cubes anymore. And so I co-found this, start a real company, not just a name on the internet.
Now, what do you mean cubes? Sorry, and let's not skip over
California. I'm talking about.
I see.
Shit,
I completely agree. But what were you doing in California?
It was IVR stuff. It was
Oh,
voice
more of that
attention
stuff.
and
I
stuff
see.
like that. Yeah, and you know, and that's the thing. The more you do something, the more you're going to do of it. I mean,
Yeah.
if you don't want to go to China, don't learn Chinese, because if you do something, that's what you end up doing. So I was slowly transforming into the phone guy. I was getting offers for you know, POTS jobs and stuff like that, and I realized, wait a minute, I don't want to be the phone guy. And it's funny because it happened to me again with electronics. I'm looking at you know, what's his name, Fedivel guy there. Anyways, he does these really long, really good videos on specific topics, and he was doing this stuff, and he's talking about, and he's good, and you're checking out these videos, and you're learning a lot about, you know, floor planning or layout and stuff like that. And so I'm getting pretty deep, you know. I'm this is a period where I'm learning EMC, where I'm learning to perfect, you know, a board design. And he's talking about this stuff. And so he's routing SRAM or something. So this high speed signals, you have to deal with skew, the traces have to be the same length, and blah 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 blah. And so he's talking about this shit, and then I'm like, I'm really interested, and I'm learning a bunch of stuff. And then he kind of mentions yeah, so I spent 3 days or a week or whatever doing this RAM. And, you know, so I'm walking around later on and I hear that echo, a week routing RAM, a week routing RAM, a week. I don't want to spend a week routing RAM. No, no, this is the wrong path. So the short of it is, the more you do something, the more that's what you do. So what my technique is look, do something you find interesting, and more of it will come. You know, it looks magical. It's not The Secret or anything like that. But from a perspective of just a global perspective, it does look like that. You know, the more you're smooth, the more you're in flow, the more that's your life. You know, the more you're stressed out, the more that's your life. I mean, just choose. They've done tons of studies where they, you know, where when they're priming people for psychological studies, you can be primed to be happy or primed to be sad, and they'll show them the same picture. And the primed to be sad people will see the bum in the corner, you know, and all this. And the primed to be happy people will see the kid with the balloons and the blah blah blah. Same picture. There's just way too much information. So our filters preset, you know, our emotions are basically filters for what to pay attention to. And so all of life is like that. You just kind of decide you're going to do this, and then that's the doors that you see open, and that's where you go. I mean, like the ASIC stuff. Yes. So I did a few contracts on a few different jobs that ended up having ASICs involved. So one of them was this really cool low power backscatter comm stuff. So Wi-Fi, you know, at zero power, and another was an analog neural net thing. And you know, both of these are so specific that they really needed something special to work. So they had these ASICs designed, and they taped out, and they actually had these things. And I was like, this is really cool, and I'm using it, and I'm doing all this stuff with this stuff. But you know, we're looking at these drawings, and I kind of get the analog, blah, 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 this is a, you know, current source, this is that, but I don't know how they're making this. And it seems really overwhelming and complicated and blah, blah, blah. And their tool chains are horrible. I mean, there's meetings every week or two. You know, the team that's working on the ASIC is talking about the servers and the licenses and the seats, and please get off of your seat because I can't use my stuff, and blah, blah, blah. And it looks like a nightmare. So, but the topic is interesting. So anyways, long story short is I end up registering for this course, the Zero to ASIC thing. And I'm like, yeah, I'm going to do that. All right, open source. It's going to be awesome, and blah, blah, blah. It might be more rough than using the big boy stuff, but I can do it. And so I'm just sitting on this for a little while, because, you know, contracts and you know, keeping the lights on work to do. So I'm doing that. But I think around the new year or something like that, I end up going, okay. You know, I registered for this class and I'm not taking it, so let's go. And so I start paying attention to this. And it just so happens that Matt is looking for help with the course. And, you know, I'm interested in the topic, but also in the approach. I'm really big on the whole open source thing. I mean, this stuff is important It's infrastructure. It can't be in walled gardens. It can't be hidden away. People need access. And, you know, the whole advantage of a city is that mix of people and ideas. If you separate everything out, I mean, there's a whole story about HP, how they had their R&D departments all split around, and it just fucked everything up. You put people together, whether it's physically or virtually, and you start getting this compound effect, all these network connections. So anyways, the open source thing is big for me. So I'm like, I really want to do this. And Nat is looking for help on the course. And so I end up going to him, hey, man, you know, I haven't actually finished the course. I'm kind of just starting, but I'm really interested. So maybe I can help you. And, you know, you can say no. I mean, I understand, but I'm going to be putting out videos and stuff on this anyways. So up to you if we work together or separately on the same thing. And it turns out he's a really cool guy. And I've been working on him, and we're doing a whole bunch of stuff with the course, taking it to the next level and shit. And it's going to be really cool. So like I was saying, you look at something, you go to that. It's like when I was doing motorcycle class, target fixation. If you're looking at the truck, you're going to hit the truck. If you're looking in the chasm, you're going to fall into the chasm. Look where you want to go, not what you don't want to see. Yeah,
I completely agree with that. But actually, what's it? Enmigen. My very good mate, Sebastian Borodok. He's actually the author of Migen.
Really?
Do you know, there's a history of all this stuff going together. So Sebastian, okay, are you familiar with MLabs?
Yeah, it is familiar, but I don't remember why.
Okay, so mlabs.hk, that's my mate's company, and he back in what was it, even 2000, at least 10 years ago, there was some software called the Milky Mist, and the Milky Mist, it was basically a system on a chip. It was an all open source platform using the Lattice FPGA, and you know, it was all hand coded Verilog. And Sebastian took one look at this and was like, "Fuck this shit!" So he created Migen, which basically took a subset of Python language, and then created this thing, and then this thing creates the Verilog, which goes onto the FPGA, right? And then then he hired a fella to upgrade, or not to upgrade, just to make it more flexible, Enmigen. And then there was a bit of a hostile fork and some rather political situation that arose.
And they changed the name because of more political crap. I'm not too sure what the story is.
I'm quite familiar with the story, but it's a lot of it was not fun. But anyway, so then I think what's it, Yosis? Then and then the Wolf fella, he created the first, what was it?
He reversed the bit stream, and then
that's right.
Yeah, the Lattice stuff. I mean, yes. I use Lattice kind of reluctantly because they're not helping. They're not participating. I mean, come on, FPGA companies. Who cares about this? Yes. You'll get a million people doing stuff that eventually some of them become real products and shit if you just open up a little bit. So I'm going to jump on to the first one that's really open, Anyways.
And Lattice is the most open one, I believe.
But on purpose. It's just the thank you, but at the same time, these guys are being jerks. I mean, once you're in front of this, okay, well, they've reversed it, though we still have some little nuggets in there that are specialized and they don't know how to use. What do we do about this? Oh, stay quiet. No, go, okay, let's embrace it. There's a ton of, have you not seen how many chips have been sold and put into people's hands? And the reason that Microsoft and Google and all those guys open up their stuff to universities and whatever is so that the people will know, I'm familiar with these tools when they go into business. Yeah. Well, do the same thing with your FPGA and everybody wins.
I don't know. Yeah. No, Sebastian's been fighting that fight for many, many years now. If you use the tool chains which is associated with these, it's an absolute nightmare. It's bug ridden, it's infested with this.
They're gigantic. and slow, and it's like
gigabytes.
And instead I have in the Amaranth and MyGen, whatever, I have this one command, and it's like build and burn, and then it just goes, and I don't even have to think of the tool chain. Thanks to Wolf and MyGen and Yosis and all of those things working together in
it's
a nice
great, eh?
everybody has a job way.
It's great.
Nice.
I love that. I love that. And even though I've been, I drink beer with Sebastian almost every week, I did not know that you could use MyGen to actually sync a design down into hardware. I thought it just went to the FPGA. I didn't know you could actually take it down to hardware.
Well, that's the thing. The PNR stuff.
What is PNR?
The place and route.
Oh yeah, sorry. Yeah,
the things that decide what's connected to what is like lower level, and it's happening Yosis levels kind of thing. So you're at MyGen and you go down to Verilog, and then Yosis takes Verilog and tech maps it to modules that are available. And then the next route or whatever, the PNR stuff, actually wires this stuff together. So these levels are completely separate. You can play in the high level and just say, I'm going to generate a nice Verilog, and someone else, the Unix job separation thing, will handle that. And so you have a back end for Lattice, you have a back end for another FPGA. Hey, you have a back end for the Skywater PDK. Cool. Now we do hardware. Really great.
How is this? Now you're doing the guitar tuner. This is an experiment of taking some Python code all the way down to hardware. What's the learning process that you've gone through in this position in this process? Sorry. I mean, it seems reachable. Like I see you doing this, and I'm like, I want some of that cocaine, please.
yeah, no, for sure. Look, the thing is, it's. I guess I came in late in the game. It's going to be MPW 10, it's the third tiny tape out. It's easy. I mean, it's a little too easy. So of course I'm going to push it to analog and whatever. But here's the thing. So I did a guitar tuner just because it was funny, and also because I was aiming for tiny tape out. As part of the course, you can actually be on a shuttle and do a bigger design with more flexibility and whatever. Tiny tape out, however, is much smaller. It's all digital, and blah. It has all these restrictions. However, it's happening right now, so good. I can start with this. And we did a workshop in Berlin actually for the tiny tape out thing, and we had people who had a bunch of experience, all the way down to pretty hardcore FPGA, maybe some hardware, but I'm not sure. And up at I don't know what an AND gate is, okay? And all these people, I mean, I'm not saying they all made it to a tape out, but they all advanced in that 2-hour workshop, because there's this GUI that you can just drag and drop your little logic gates, and it's pretty sweet. So my point is, you don't actually need to care if you're doing digital about the hardware. So I was like, okay, I want to sculpt some atoms. Okay, I want to place transistors. So let's do this. I'll do it first level, just easy, let the machine handle most of it. And so I did an audio application, because tiny tape out up to now has had limitations in terms not just of space but of speed. And so because all the projects, when you get your chip, all right, well, you're getting everybody's chip. Okay, all the projects are on there at the same time. Oh. So you can decide, hey, this project looks cool. I'll just set the switches and talk to that one instead of talking to mine. So cool. But the way it works, the first implementation was straight up, this will work, but it wasn't ideal. It's a scan chain where you're sending your clock, your bits, your whatever, through everybody. And it winds its way through every project, and then the output comes out, and only the project we're talking to actually picks it up. So that really slows things down. I mean, on the hardware, you're talking about a whole bunch of megahertz, no problem. But actually getting your data to it and out of it, super slow. So we're talking tens of kilohertz. And so I was like, okay, audio. Cool. So I do this thing, and the learning curve, I mean, I've been learning I've been spreading out. You could go super linear fashion and say, I'm going to do the course, and then you do the course. I'm completed and I got my little badge. Great. But you know a little bit more, but I like to know a lot more. So while I'm doing this, I end up going, okay, well, hold on, simulation. We need to do simulation. So I dug out my, dusted off my spice and started playing with that a little bit deeper. And then the VLSI stuff, the how this works, how do you make a transistor? Well, that's a whole other area. And then all the weird stuff about parasitics and how you do decoupling caps and how you blah 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 blah. Everything is complicated. Okay, there's nothing not complicated in life. As soon as you pay attention or just look closely, the depths of complexity. Okay, parenthesis, if you don't mind.
Go for it.
I remember the thing. I remember seeing this thing, and it was about life on Earth. And the guy was saying, we're in a tiny sliver of animal life. Before, there's a big chunk of bacteria. And then now we're in the animal sliver. And after will be a big chunk of bacteria. So here we are in this tiny sliver, but our mind kind of goes, this is what life is, the magic, all the complexity, all the blah, blah, blah. Yeah, okay, but you're just extrapolating from what you know. And we do this all the time. And, we think evolution equipped us with a bunch of heuristics, and we think like linearly, but nothing is like that. And all our science and all our applications, they all apply and they work. I mean, it's awesome. But they work in this tiny zone of not so complicated, right? All these, ideal gas law, all these kind of general rules of thumb. We're just kind of doing the same thing as our brain, and putting it onto the world. And it works great in that tiny zone. But complexity is hidden everywhere. I mean, I was looking at something at the Mandelbrot set. Okay, you can get lost in this. But the point is, okay, my favorite illustration of wave particle duality is like a can of soup. Okay, you've got a can of soup.
Okay,
a can of soup and a light. You can shine your light on it, and what you see, Plato's cave style, is the shadow, right? So you put your can of soup this way. Hey, it's a rectangle.
Oh yes.
This way. Hey, it's a circle. Hey, it's the rectangle circle duality. Yeah, no, it's a can of soup. Okay, but you're too dumb, and all you've got is one flashlight, and so there you go. And everything is like this, and so we're looking at the number plane, and I mean the number plane, infinities, and all this weird stuff. But if you rotate it, if you look at it in a certain way in one certain space, basically, apply that recursive algorithm that gives you the Mandelbrot set. Well, any point is kind of simple to explain. I can condense the Mandelbrot set in this sentence. Here's the formula, do this, and then just do it again. And if it explodes, then it's this color. And if it stays steady, it's this color. Well, cool. But that doesn't tell you shit. If you do it on one point, you'll know something about that point, but you will not know anything about the points around. And so all that complexity, all that incredible craziness is buried in there. And that's just one way of looking at the plane. So everything is like this in my mind. Everything is super deep and super complicated and super interrelated. And so, life is too short. I don't have time to look at it all, but I sure want to. So the point is, this ASIC stuff, I start getting into it, and the progress has been slow. I'm at module 3 of this course because progress in the course has been slow, but in my mind it's been bubbling like crazy, and I'm doing all this stuff. I mean, there's CocoaTB, there's all the testing frameworks, there's the cover stuff, there's all the physics of it, there's blah, blah, blah. But if you want to step back and not get the overload from this, then you go, okay, look, what I need to do is be able to express myself logically. And if you're a programmer, well, you're done. I mean, it's done. You can do this. If you can describe something, you can do this. The only hard part about Enmigen, Amaranth, all that stuff is remembering that you're not writing the program, you're writing the description of the generator that will create the program. So you're a level meta behind, and you have to think in hardware. When you're thinking software wise, your brain is like set that way. You're doing these algorithms, you're doing this step-by-step stuff, which is unnatural to hardware. Hardware wants to do everything at the same time, and that's an advantage and also kind of a trap. But if you're thinking as an algorithm, like I did in the end implement that SHA-256 thing, I called that one Shaman. Anyways, so when you're doing that, that is step by step. And so then you have to force the thing into serial mode by creating a state machine or something like that and just go clunk, clunk, clunk. So the point is, if you can get up over that, and if you've done FPGA, well, you're done. I mean, that's it. A programmer has an advantage. An FPGA person is done. You don't have to do anything else. You can just write Verilog if that's your thing. But once you do that, it's just about saying go to the process, and it takes 5 minutes, and you have your design. It's insane how it's easy.
Hang about. Okay, so the output, so you press go, 5 minutes, you have your design. You can go off to any fab anywhere in the world and just hand them this thing.
Oh, not quite. Close. So you have your design. So here we were in Python, and then we went to Verilog, and we're still describing hardware. We're describing logic, right? This gets converted by Yosis to something that can be fabricated. But
what is that thing? What is the name of that thing?
That's just the thing that you send to the fab for tape out is to the foundry. Sorry, I'm used to other words, but
foundry,
is a GDS file, which is like a Gerber. It's old school. Here's some rectangles. It's just a drawing, right? It's a description.
It's just a Gerber. Jesus.
Yeah.
Of course it would be a Gerber. It's hardware.
A Gerber layer by layer. Same idea, right? So except that the layers, instead of being this is metal, this is a silk screen, this is this is a mask for diffusion of protons. This is a mask for diffusion of, of doping of this. This is a mask for an oxide, stuff like that. But the idea is completely the same. I mean, it's exactly the same. Now, how that mask is produced is basically you're taking little Lego blocks, and the Lego blocks will be, well, okay, it's in 2 steps. First of all, you break it down to the smallest 1-bit operations that you can. I mean, Yosis. And so everything is just, inverters or whatever. And then the system says, okay, I could do this. I could take the Lego blocks from the PDK, okay? And the PDK is process dependent. So the PDK says, well, if you're doing an inverter, these are the sizes. This is the drawing, actually. You don't describe anything really complicated. It's just, this is the drawing, and this is where you connect the power, and this is where you connect the input, and here's the output. Simple. So you could just stick those drawings everywhere in a plane and connect them with little metal wires on the appropriate layer, and you're done. But it would make your design gigantic when there are optimizations. So the PDK doesn't just have inverters, it has a whole array of choices of everything. Specialized, here's a 3-input AND with an OR, here's a 5-input inverter, here's a buffer, here's a clock thing, here's all these pieces. And the job of Yosis, or whoever's doing this in there, I'm not too sure anymore, is to say, hey, look, we can actually kind of put all of these 1-bit operations together into this, and it'll just take this block instead of having a bunch of little blocks spread around and wired together. Cool. So there's an optimization phase that is also extremely process dependent, because not so much process dependent. The process sets the sizes and all that stuff, and the tolerance and blah. But what did those guys make for us? What did they make available in this PDK? Which optimizations can I possibly do? And so somehow the tools read this stuff in and say, okay, I can combine this together with that, blah, 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 and use this block. There's one. And so you do your it does the placement, and then it does this global routing where it says, okay, this is kind of going this way, this is this way. And then it does, detailed mini routes. And your only hard thing, like the Shaman thing, the SHA-256, is, was it Knuth or Booth or whoever? Premature optimization is the root of all evil. Yeah. Well, guilty. So I was like, oh, well, the W operator needs 16 times 32 bits, and that's a lot of bits. And so I'm going to kind of just reuse that, and it flattened the design and blah, blah, blah. The point is, it ended up, 5 minutes is my Neptune, my audio tuner design. This thing, I let it run. I just, who knows? We'll see. 2 days and a half. Optimization 10. It was taking 7 hours to do 10% optimization, and it wasn't even reducing. And I was like, okay, I give up. I need to try again with more. And it wasn't about space. It was something else was wrong with the design, but I'll play with it and see.
So I was watching another video where they were describing using the proprietary tools, and apparently for, I believe was it a single transistor, there are potentially over 100 different parameters that can go into that single transistor. Does your system, is this the process that you're talking about, where it takes all of those different parameters and sort of bundle it up into that little block that you spoke about? Or do we know enough information to continue with this conversation?
I'm not sure I have enough expertise on that, but I can say this: when you're playing with Magic, which is a wonderful name, but also terrible for SEO. Magic is basically a way to draw your transistors. Okay, so if you're doing analog or stuff like that, you're not just going to take the PDK and plop in Lego blocks. You're going to draw squares, squares on layers, and then the tool does one thing for you, and it says you violated the DRC. Okay, this is too close, this is too small, this is blah 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 blah. So the physical limits are related to the PDK. But let's say you are wise or conservative and you draw something that doesn't violate any rules. Magic does another thing for you, and that's extract the spice. It actually figures out based on, it goes, hey, this is a resistor, hey, this is a capacitor, this is a transistor, but it has straight capacitance. Oh, okay, wow. This is an old program. I mean, I'm not sure how much it was updated, but it is really disgusting to use and also incredibly wise. I mean, it does magic. So if you're doing analog, that's the world you're going to be in, and you're limited by the PDK in terms of sizes and how close you can get stuff together and all that. And this is where you're thinking about all those parameters. Okay. Now, when you are doing it digital style and you're taking those Lego blocks, you're not drawing squares. So, assuming they've done a good job, the things are manufacturable and they have a certain, and they'll perform. They've made the trade-offs already, right? They've decided that this is going to be low power, but you're going to pay because it's slow, or, the inverse or whatever. And so what you get is the drawing and some spice. I don't know if it was extracted or how they generated it, but you've got simulation data that you can use for, I use this block, this is the sim that goes with it, this is the model. Okay, cool. So yeah, the guys designing the PDKs are considering all those things, you would assume. But I, at least way up here in digital world, am not caring at all. I'm going like, please do a good job, and that's it.
All right, I got you. No, there's a lot of that crossing fingers when we're up in our domain and we hit compile. Please, God.
Yeah, there you go. I think it'll be okay. But yeah, I have no idea, for instance, why my second design, the bigger one, I mean, it was definitely 500% too big for tiny tape out. It was gigantic comparatively, but I don't know why I didn't get a GDS out of it. And I, other things to do, so I haven't investigated, but I will.
Now, has this tiny tape out? What you receive in your hand is a chip, right? With GPI with pins, right?
Well, okay. So for tiny tape out, they're nice enough to mount the thing on a PCB. Hooray.
Oh.
Now, if you're doing the MPWs, if you're going on the shuttle and you actually win a ride, what you get is, if I remember correctly, a PCB with the chip mounted. So it's packaged and it's mounted. And then, 30 chips. Good luck. And these are packaged however they're packaging them. So it could be a BGA, it could be whatever it is that's coming out. They don't always use the same thing, and I don't know why. Sometimes it's QFP.
So the format, the profile of the packaging would vary. That's kind of shit for creating a product.
Oh, well, no, but you get to decide. I mean, it's just
Ah,
how
I
much
see.
are you going to pay to have this mounted on there?
I
So
see.
some boxes are easier to use, but boy, they're more expensive. So here you go. Here's a BGA. Enjoy.
Oh, I see. Okay. And now this you called it, no, I called it, if you called it a foundry, where is this foundry? Would they ship it off to Taiwan?
No, actually, I think Skywater is in the US.
Oh,
So now here's the thing: the Skywater I keep talking about, because that's the basic thing that I think it might have been the first. I don't know, but it's open. It's an open PDK. Good job, and it's creating all this bubbling of activity. But there are others. There's a couple of academic ones that are useless. And well, no, but I mean, you can. It's a controlled environment and blah blah blah. But you can't manufacture this stuff. So yeah, okay, enjoy your research. But I need to focus on something else. So that there's Global Foundry 180, and you know these numbers. It's so stupid. You know, back it was related to size. Now it's just numbers. Like the 130, I think the minimum feature size is 150 nanometers. So, you know, but we need a smaller number because that marketing. Anyways, so the point is Global Foundries, which I think is in Taiwan, 180 is a process that's open or going to be. I'm not too sure what the status is on there. Skywater, the US, definitely open. We've used it a bunch of times. And I think there's a third one that I can't recall right now. But
and typically for each tape out run, how many? What's the cost of that? And do you share it amongst all the participants in the group? Is that correct?
yeah, well, that gets complicated because you've got standard style, you've got hot lots, and you've got I don't know what. So in short, if you want your wafer to be filled with your chip, you're going to pay hundreds of thousands of dollars. The masks, it's insane. Okay, it's maybe more. I can't even remember what they paid with the backscatter thing, but it was expensive and still pretty slow because there is a speed up process. Like we need this right now, and we need this right now as a hot lot where basically there are steps. You know, there's a million little steps of okay, and then we do this, and then we polish it, and then we do this, and then we polish it, and then okay. Now a
And
hot
inspect
lot
it.
will.
Yeah, keep going. Sorry.
So the hot lot is a serial process. Your wafer will go from station A to B to C to D in that order, one after the other. Wonderful. And it will come out the end. It's just not that long. But just like FedEx might ship your package by going halfway around the world because of efficiencies in their process, not speed, efficiencies. The way the wafers are made is that okay, now we're doing these things. And so this batch, and you go in and you do this doping and blah, blah, and then it just sits there. And it sits and sits and sits until it's ready to get to the next stage. And so I don't know how they optimize all this, but instead of taking a few weeks, it's months and months. So that's one thing. So, but it's cheaper, of course, because you're letting them decide when things happen. And so that's one part. The other thing is the wafer. So you've got an 8-inch or whatever it is, you've got some wafer, and well, is it all yours or not? If it's an MPW, it's a multi-project wafer. And in that case, you're getting a chunk of it and you're splitting the cost for the masks. I mean, the process is something, but the mask is where all the cost is. So you're splitting that cost between everybody who got a chunk. And so as far as I know, look, I don't know if the Google Skywater, EFAB stuff is using the whole wafer or not. But the point is they have these shuttles where they'll take a chunk and then put many things in the chunk. So it might be part of the equation might be that every part of your chunk has to be the same size. But whatever the reason, they use Caravelle, which is like the equivalent of the PCB on which the chip goes for your project. So it's got a little CPU, it's got some memory, it's got pads and blah, blah, blah. And then your project goes in the middle of that thing and connects out to it. And then it is the same size, no matter how many projects there are. They're all little rectangles that look the same. Slice that up, package it, wire, bond wires or whatever they're using, and then everybody gets their thing. And on the inside, in the middle, they're all different, but around, they're all the same.
Oh, I see. So that same rectangle would be it's just the connecting wires to that little rectangle, which would be different for each. Like, for example, so obviously that process would be a little bit cheaper than to. Well, that's yeah.
Oh yeah, I think we're talking, if you want a chunk of wafer for your project inside of one of these shuttles, you're talking a couple of K, 10K or something like that, to 10K. I'm not too sure. It depends on size, but it's not so bad. It's slow.
Okay, so we're talking about maybe a couple of months before you get your little tiny tape out thing in your hand, your guitar tuner.
Yeah, and it's kind of like, pray to the foundry gods, because it might be sooner, it might be later. It's like, who knows who else went, hey, I want a hot lot and I'm going to pay you lots of money, just bump all these people back. Okay.
I see. Well, that's fantastic to hear all that. Well, should we change track a little bit and talk about your electronics, the work you've done with electronics? How long have you been doing electronics and designing? What's the scope of your work? What's the most interesting project you've worked on? That sort of thing.
Let me get my coffee. Hold on.
All right, man.
It's been getting nice and cold.
I'm on my beer. You're on your coffee.
Yeah, well, we can't be much further away on this ball of mud.
We're on the other side. We're on polar opposite ends of the world. Yes, yeah. Nearly 9:30 p.m. my side and nearly 9:30 a.m. your side.
Yeah. Wow. So yeah, coffee it is, but cold like your beer. Electronics, yes. So the bread and butter, what keeps the lights on and stuff, has been a lot of, obviously, IoT and things like that. I've done and this started back in the pure software days. I mean, I've always liked being see, I'm a hobosexual.
What?
I just find how disturbing that sentence is appealing. It tickles my brain, but really, I'm kind of a Ronin. I end up coming in and fixing a problem or doing some project and then like stepping back most of the time. So this allows me to see the back store, to go into all these. When I was doing software, I did these things. Some guy, he was specialized in shipping tiles, and the tile shipping world, they're heavy. And so, yeah, you use DHL, right? But more than that, there's specific weird things about it that are interesting. There was an amusement park, okay, so you get to see the backstory of how an amusement park works, stuff like that. In hardware, it's kind of similar. So I end up doing a lot of, in order to solve your problem, I need to understand it, and in order to understand it, I need to understand what you do. So that's like step A. Okay, what's the problem? And who are you? And because a lot of clients, some of them are companies and they're pros and they know where they're going, but a lot of them want something, but no, they actually have a need to fill and they want something, and those two things don't necessarily go together. So step A, figure out what's going on. Now, like I said, often it's been IoT, the classic sense, compute, actuate kind of thing, report, use, you're looking at GPS and position and you're sensing the environment, and you're using Cat M1. I mean, at some point I was one of the first to use Cat M1 around here, which is machine to machine, like NB-IoT, for this project, because it's low power LTE basically. And so stuff like that. But then there's weird stuff, these research departments for companies and universities, and they do special stuff, and so that gets pretty interesting, like sensing medical sensors. And once I got called in to basically troubleshoot an EAP or whatever, electroactive polymer. It was basically a polymer that was like a muscle, right? That moved through electricity. And this one was really weird because it was physics instead of being electronics. I mean, so I ended up with the white lab coat and the little glasses with like real life juicy chemists doing juicy stuff, and it was like, wow, this is really cool. And it was kind of strange because they were like, it's not reacting as strongly as we want to, and why? And they were doing all the chemistry but not thinking of the physics. Anyway, so I brushed off my
never say that to a chemist. Never say that to a chemist. They get irritated.
Okay. Between you and me. But anyway, so yeah, you know, weird little stuff like these sensing environments for mouse models, and dashboards for go-karts, and you know, all this weird stuff. And then the deeper, you know, like the backscatter comms thing, I did a long time with this company. And it was great because, okay, so backscatter is a way to, you have an antenna, and if you're receiving signal, well, you're doing something, right? Nothing's free. You're impacting the field. And so if you toggle receive, don't receive, there's an echo, there's a bounce back. The field is impacted by use draining it or not. And so
yeah, that's right. Yes.
There ain't nothing free. So you can use that to your advantage, and that's what backscatter communication is. You're toggling your antenna on and off. Basically, you're not actually paying attention to what's on the antenna. You're just sucking the field, and the other side is seeing you do that, and so you're communicating without a transmitter. oh, tasty. So that's really cool. And that was one of the most full stack, I'd say, kind of projects I did, because you were down at the EM fields. And I mean, the EM field is the fields are fascinating. I used to, you know, go like, oh, ham radio guys, you know, they're all so obsessed with their damn antennas. An antenna is an ugly little piece of metal on a roof, right? But that's only if you're looking on the outside. Like I said, everything is complicated when you look closely. And the physical portion you see there is just the hard part. It's actually a 3D structure. It's a 4D structure. It's the field interacting with this thing that is interesting. And that's why ham radio guys are, I mean, I don't know, but are into their antennas. So that part of the physics was really interesting. And then you had to go up, you know, build it, make the electronics and the circuits and all that stuff, and then use it, and then analyze it. And then we're talking about GNU radio and all this. And this was a whole world. And that actually convinced me. I was like, okay, no, this is actually lots of fun. And I got my ham radio license from that point. I was like, okay, I'm doing this. So that and the analog neural net stuff. I mean, this is getting cool because, you know, we're talking, this was another ASIC, you're talking super low power, right? So what you want to do is brain type stuff where you're recording the information, the structure physically. You're actually changing the properties of those FETs in there.
So, okay, are you talking an already trained neural net? So you've trained it, you've spent 10,000 hours or something training it, you've got the output, and then you put that onto hardware.
Well, what is your output from training? It's weights, right? You have a structure, but the important thing is, okay, if this one's on, but not this one, and this one's in, these pixels or whatever it is, it will be processed differently by the weighting of these inputs and how they're interconnected. So what you do is you play with the weights. And how you do that without it being a bunch of RAM that you have to go to and figure out, well, what's the weight and everything, those bottlenecks go away. I mean, we don't have, I eat a muffin and I can run this processor, not so fast, but in massively parallel, all day, right? So that's the same idea, because the weights, the work was done at some point to record the weights in my brain and in this chip, by changing the properties of the gates of those FETs. So that's pretty sweet. And I mean, this is a problem with MOSFETs. They have a tendency, these stray electrons get in there and they change the threshold. Yeah, but you can use that. That's really cool. So I didn't get to play with the chip because this was before I got into the ASICs, but I did get to play with the chip because they had taped out, and we got to mess around. It was a lot of fun.
So you built the board, the PCB around the chip and the software stack. How did that work? What was the?
It was mostly about characterization and like profiling and figuring out how this stuff works, because this was the very first tape out of this thing. And so they had the idea and they had the models and blah blah blah, and then they taped this out, and it's like, okay, but real life, let's look at real life. And so it was all about, does this work? And then, okay, how does it work? How much can we affect the weights? How can we train it? How can we blah, 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 blah. So it was a long story. It was really interesting. Canadian company that are going to do some pretty interesting stuff.
Oh, okay. Anyway, but, so yeah, but you probably can't go into too much information about that.
I cannot. No, that's pretty much the limit.
I understand. Okay, so the electromagnetic field. Yeah. How far could you actually communicate between these devices?
Oh, well, how much do you want to invest in your receiver?
Oh, I see.
So there's a noise floor. I mean, you know, and that was a whole, okay. The short version with this is they ended up bringing this wildly, insanely awesome dude who had worked a ton on actually the IEEE standards, the 802.11, but also on RFID stuff. And RFID is funny because well, whatever, RFID stuff. So the point is,
bookmark that. Keep going.
Bookmark everything, man. But the point is, right. You have a lab set up with a receiver and a transmitter or whatever, the backscatter module, and you're doing tests, but the world isn't an empty room. The world has walls and objects and soft, mushy things and hard, bouncy things. And so it all becomes, it's not just about the noise floor and the sensitivity and da-da-da. I mean, GPS, do you know that signal is below the noise floor?
No. Define noise floor. Define noise floor, first of all.
Oh, if I have a pretty good receiver and I turn it on and I boost the gain, well, there's a
yes,
right. Well, what is that? It's noise. It's a noise from inside the circuit, because we're not at 0K and everything is jiggling. And it's noise from the field because nothing is empty. Even if we were in the middle of outer space, the 0 point energy, right? The quantum fluctuations. So quantum and Heisenberg and keywords to bookmark. And so, and so this floor is partially related to your equipment. Your thing is making some noise, how good that is. But at some point, you're going to hit a limit. No matter how good you make it, even if you freeze it at 0K, then the world noise is the noise floor. But whatever it is, here it is. And GPS satellites have to run a long time and blah, 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 and they're far away. And so they blip down, as far as I know, below this noise floor. And the old, SNR, right? Signal to noise ratio. Normally you need more signal than noise to be able to pick up the signal. But there are ways of spreading things around in frequency domain or in time domain and blah blah blah, and then you end up putting it all together and focusing that lens and getting a signal. So part of it is sensitivity, and part of it is how you do this modulation. Wi-Fi itself has a bunch of different, good old 802.11 what was it, A or whatever, is a completely different protocol than G.
Yes.
Okay. So the way they're spreading that signal and injecting no noise into it and blah 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 and making it noise proof is interesting in itself. But the point is I don't have an answer for you because there's too many dependents, and also they this was at least a year ago, I can't remember, but I mean they have moved forward. So
Right.
my initial tests, when I was basically in the lab, and I had this horrible setup with wires everywhere, and it's like, okay, and I managed to get it across the room, no problem. I was reading this stuff with new radio and SDR, and it was super fun. but the point is, you could see it going, and I was like, wow, man, and this was, the worst setup ever. And we didn't even have the ASIC at the time. I was doing it manual style with an analog switch. Anyways, so
Fascinating. Absolutely fascinating. Good grief, man. Good grief. So now the future direction that you want to go in, are you going to continue with the electronics, or do you want to get into like the ASIC design and whatnot? Are you getting bored of electronics? How's it?
No, there's no. I
try to focus your camera.
Computers, I like capacity. I like being able to do more and to allow others to do the same. So I grow my skills and then somehow find a way to try and share it. And so the ASIC stuff is, I mean, we're democratizing access to being able to make these chips with the open source stuff and the courses and all that.
Let me press pause. Can you refocus your camera by sticking your hand?
Oh shit! Look at that.
Look at
that's the camera is focused. I'm just feeling blurry because you asked me this question.
All right. Full of it. There you go. Okay. All right. You like democratizing stuff, yeah? Mm-hmm.
Yeah. So, and I mean, I'm all for that. This is a good direction. And who knows, that guy there that did the transistors in his garage, I can't remember his name. He's now starting a mini foundry thing, so it's not just access to the, yeah, I think so.
Zaloof,
yeah. Awesome. So so that's happening at the same time. And I mean, it's funny, the way things work, they always try to, oh no, everybody has access now, and they try to, and I'm talking about governments and corporations, and they try to squeeze it and shut it down, and it just leaks out all of their fingers, like nothing can be locked down. That's not how you protect the world. I mean, I have a tendency to live in rough areas, okay, like grungy,
like Montreal.
But the rough part of Montreal. Yeah. It's an easy-going, really safe and dull city. But the point is, I still like the rough areas. And so at some point I was, there's a bunch of bums and there's junkies and all that. And I was thinking, why heroin? I have not tried heroin. I'm told that it feels real good. And yet I don't want to try heroin. Why? I like feeling good. Why won't I do this? And the answer is, well, I have, I can see a little further down the line, and I have hope for the future. There are other things than being a junkie that I want to do. And so, and so that is my solution. Now, these people are, they've had hard lives, whatever the story is. They made another choice. They had no hope for the future. And so they felt good today and fuck the rest. Hypothesis. My point is, nanotechnology and the gray goo and the terrorists and the blah, 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 all this stuff, you're not going to stop it by repressing the information. That the information wants to be free, and I'm going to help it get free. Okay. The way you make most people just want to live their life. They just want to have a good time. They just want to focus on their things and be nice. And the proof of that is walk down the city streets and look at all those windows. Glass is hard to make and easy to break. No one wants to break the glass. Most people just want to live their life. So the way to deal with problems and all of that stuff is hope for the future. If you give that, then yeah, the nanotechnology, the 3D printers that are printing atoms could print horrible things, but they don't. They print nice things because I want nice things in the world, right? So I'm not sure how I got off on that tangent, but the point is the democratization, right? So the foundries, the diamond age 3D printers. I mean, the things that we will make that allow us to create anything. I mean, this is awesome. But for the moment, it's still some money. I mean, I'm going to get on the Google's being nice. Oh yeah, why is that? But anyways, I'm going to get on that shuttle and I'll get my thing produced and it'll be super cool. But then what? Now I'm an ASIC awesome guy. Well, I've got a couple of choices. I could spend, I could find a good application and something that actually needs its own chip, you know, something I can't do on an FPGA or with something that exists, but that the world needs, that I need. And so it's worth it. And I'm going to spend the money and I'm going to get on an MPW and I'm going to make some chips and, you know, kickstart it or whatever. Cool, that's possible. But how possible? I don't know. So then you end up, oh, I have all this expertise. Am I going to work for a company? Look, if someone tells me, hey, man, we have this thing that we think is worth making, and we're not just going to make it, we're going to sell it, and, you know, we'll pay the rent, but we're going to open source it, and we're going to build, and we're going to share solutions so that people don't have to reinvent the wheel. Okay, I'll work with you. I'll do these things. And so that might be a way that things go. Otherwise, you know, for the moment, there's still a need for my particular flavor of ingenuity. And so if you have a problem, you come to me and I will probably solve it if it's a worthy problem. If it's ideally something that's a little hard for me, because, you know, I do get bored easily.
How much knowledge or experience do you have of ion traps?
Very
or
little
interest.
I have interest. I was thinking, I was like, look, I can shape these transistors. Yeah, but I could do analog, right? Yeah, but hold on, I'm actually shaping little boxes in here. Could I make a diode? Okay, maybe not. Well, not a diode, but an LED. I mean, I was thinking photonics and stuff like that. And then I started thinking, okay, yeah, maybe not photonics, but what is an ion trap? I mean, what is if you make the box the right size, it can only hold these particular waves, and therefore that's basically what will end up in the box. And this becomes really interesting because you're playing at that scale where stuff gets weird. And so yeah, why do you ask?
Oh no, because well, my close friend Sebastian, he does M Labs, and M Labs does the control systems for ion traps. Lots of hardware, designed like from scratch. Lots of FPGA stuff, lots of all this sorts of stuff, and those solutions are sold to universities, to governments, and it's all open source hardware, all open source software, but yes, but importantly, the optics side of things is very, very proprietary. It's all circulating between these German handshake companies like Toptica, who have these expensive boxes that shoot out this and you've got this optics table with all these lasers, I mean mirrors and whatnot, and beam splitters, and everything's very expensive. Well, Sebastian, over many beers and sitting in the what we call a Dapai Dong here in Hong Kong, which is basically like a very grungy, dirty, like there's rats running around.
All right. Okay. This is where we're going when I come to see you.
Yes. Getting pissed on cheap beer. And then we're discussing, we're like, well, why don't we use, I mean, because lasers They're everywhere in telecommunications, but because of economies of scale, right? So what happens if you were to create an ion trap using telecommunications lasers? And this is what Sebastian is working on now. This is his hack project. So you can reduce the costs. You don't need to have an optics table. You don't need to have all this expensive equipment and whatnot. No, you just contact a couple of Chinese companies and you say, hey, listen, can you dope your fiber with this particular element in here? And they're like, yeah, sure. That'll cost you 12 renminbi. And you're like, what? Are you shitting me?
Okay, I'll pay.
Yes. Like the most expensive equipment in there is, I think it was about $100 and it's fucking insane, the kind of shit that's going on. If you just look at it from a different angle and you think, well, let's all the designs that we just do it from the perspective of using equipment that is within the domain of economies of scale. It's just a design constraint, but it kind of opens up things in a different way. Sure, you can't use calcium, you can't use these particular elements to trap an ion. You have to use like lanthanum or some other fucking obscure niche thing with like multiple peaks on the the spectrum, which makes it more difficult to be able to find sorts of things. But the thing is, it's interesting.
It's interesting, and those difficulties, when you're forced to face them, you often wind up stumbling onto other interesting things because no one's looked there. Because why? This is hard. Whatever, we can do this, then we have the money anyways. Let's do it. Okay, good. But let us face this thing and see what comes out. And who knows, man? A whole bunch of shit could come out.
Yeah,
exactly. And even if it doesn't, you still end up winding in a situation where, hey, look, we basically made this thing and now it's COTS, it's off the shelf. Here you go. You can do it too.
Yeah. So I mean, that's just some of the shits and giggles that we get up to. Good fun. Yeah. But now have you much work with the LoRa network, LoRa networking?
The last thing I did with LoRa was it was rigging construction sites. So construction sites have so they're bringing up big poles or whatever they're bringing up high, and the riggers, they have a dangerous life, and it's slow and it slows everything down, and they have to go up there and untie the whatevers. So these guys make these hooks that are just remote controlled. Okay, but for range and security reasons, LoRa was the way to go. And so we had actually, I'd proposed, and I think that was a way they were going to go, but I don't know if it's happening or what. Proposed, because there's a whole bunch of layers to this. You've got, this type of device that pulls, and this type that sleeps, and this type that blah blah blah, and it's one-to-one communication. But you've got LoRaWAN or whatever, where you have a network of things, and so you can tie in a siren or some blah blah blahs and put it all onto this, basically a LAN, but over LoRa. And so you get your 500 meters, a kilometer, or whatever, no problem. So that, and then I think there was an irrigation sensing and management system that was also LoRa because distance.
Yeah. How does it achieve such distances?
Short version is, it's low power and it goes far, but it is slow. And so this is one of those trade-offs again. Talk slowly and loudly, but not too loud, but really slow, and spread it around, and it gets through. The details I'm not too sure of. And as far as I remember, LoRa had this, it has some crypto on top of everything. But
that's LoRaWAN, isn't it? LoRaWAN is the protocols on top of the LoRa.
No, but I'm talking about the low level stuff, because I remember sniffing with the hack RF or whatever SCR I was using, and it's a big mess. And this was a while ago, so I don't know. But last time I checked, there was no obvious way to. It was some proprietary bullshit that you couldn't just read. So you could see the signal, but look, this is far away, and I can't quite recall.
Okay, I understand. So I'm not going to be able to hook up my Hack RF Blue and read the data off.
I'm not saying that. There might be a way to put it, first of all, not encoded, and secondly, the world is full of people who are curious and don't like the clock doors. So and also I might just be wrong. I can't quite remember.
Well, anyway. What other interesting things can we talk about? Any other? I noticed you posted a video of a microscope where you sort of like went into these sort of like on your blood, right? Was it your blood?
Oh yeah.
What's the story there? What did you want to do there?
I'm curious. That's the story. Like I have a stereoscope, right, for doing rework and looking at my PCB stuff, and it's really cool. And it's got this focal distance that's big enough that I can actually do stuff underneath while looking. So, and it's a stereo microscope, so it's 3D, and it's really great for doing stuff. But you can't look at biological samples, all the wet stuff, because it's not strong enough and you're not shining light through it. So I end up getting this optical scope, and talking about economies of scale and everything. It's insane. We can. It's all right there. I mean, the information is all there. There's too much. I mean, when I was a kid, the hunger was natural, but the starvation was environmental. And so it left me with this, I'm hungry for information, and now I just have a fire hose. Okay, so that's the information side. And then there's the capabilities. I have a pick and place. I can start with an idea, and I've actually made the PCBs too, but now 4 or 6 layers. I don't want to play with that. But basically, I can take my time, and what I did with software was take time and transform it into value just by organizing electrons. And then I went the other way and went, okay, I'll take my time and design, organize physical things into value, and that's electronics. And now I'm back to organizing electrons almost with the ASICs. But the point is, all this capability, all this capacity is available to us for super cheap. So this microscope is, I don't know, $300-400. It wasn't free, but pretty close. So I get this scope because I want to be able to see. Actually, I was curious about soil samples. I'm kind of on the side because, why not, was getting curious about permaculture and things like that. And one of the big things is soil life, all that. Again, what's the probability of life occurring? So the primordial soup, and then you have a self-replicating molecule. Well, the probability is pretty low, blah, blah, blah. But autocatalytic sets of molecules that make a circle and generate themselves, that is actually more probable, although it looks kind of weird. And so everything is interconnected, and life is the definition of life is much less broken into things. I mean, every time
much less clear cut. Yeah.
There's nothing clear cut. It's all just one big soup, right? But anyways, so soil is the same. I mean, plants don't, it's not symbiosis, it's one fat organism. Plants send like 40% of the energy they collect from the sun through their roots, and they spit it into the ground. Why? Because they're feeding the guys who break down the blah 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 that feed their roots. I mean, it's a whole system, and it's amazingly complex. I mean, they are basically ordering from a menu. What I need now is this. And so they'll spit out these particular sugars, and those particular bacteria will, okay, and they'll produce whatever the plant needs, and it's this thing. So, but for that to work, you need the whole ecosystem in there. You can't just, I'm going to put some nitrogen and everything will be fine. Yeah, no, you're fucking everything up. So anyways, the point is, I was curious about what was in soil. And so that's how it began. And then the scope, and then, well, what are you going to look at? What did the first person who made a microscope look at? Do you know? It was a personal sample. Let's put it that way. The point is, The point is, I also use a slightly less personal sample. And so I took out some blood and looked at that and saw what happened to it, and it was pretty cool. And then I took a cheek swab, and yeah, I don't know, maybe there's something wrong with me. There seemed to be a lot of immune activity going on. I was like, oh no. But don't ask Dr. Google, because then you're sure to die.
Yeah. No, I flew out of Malaysia about a couple of weeks ago, and you can go through, you can see certain pristine forest in certain areas, but then when you go out of the areas, man, you just see, talking about the monocultures and throwing nitrogen into the soil and whatnot. You just see palm oil.
Oh, for the palm oil things, yeah.
Yeah, it's just fucking
yeah. But we love
man.
our Nutella or whatever the fuck.
Yeah, exactly. Yeah. Jesus, no, it was awful. It was awful to see that, but man, yeah.
Well, I don't know. We're maybe everybody feels like this. I mean, it was supposed to be the end of the world in the year 1000 or whatever, we always feel like this, but it seems to me like we're at a point of convergence of crises. Everything is kind of crumbling at the same time for reasons that were built into the system from the start. And you could think, oh no, the end of the world, or we'll start fresh as cavemen, or no, I don't think any of that. I think we're just going to have to kind of change our global perspective, our way of doing things. And we're at this point, Nick Bostrom, the Matrix stuff. Bostrom, we're living in a simulation, all that.
Yes.
Well,
and the simulation is going to come back and bite us if we say something bad about it or something. I don't know.
He doesn't go that far. It's
okay.
just kind of a mathematical thing, right? It's like if humanity continues for a long time, then there will be lots of humans if you count in spread and both in time. And some of those humans will choose to simulate interesting periods. And one of those interesting periods might just be now. And so it is statistically more likely, if humanity continues now and doesn't go through a Fermi style big crunch or filter, then it is more likely that we are in a simulation than in real life. And then when you look at, the universe does seem to be quantized. That does feel, there's the smallest space, the Planck length or something. This does seem like a simulation to me. But in the end, what is a universe? I mean, it doesn't really matter. There's no difference. So, but all this to say, I feel we're in a very interesting period. I mean, we're so lucky. I mean, that is what makes me suspicious, being so lucky to live now in this phase of transition. And I'm lucky. I'm really lucky. I straddle the starvation period and this period of overwhelm of information glut. And so I think that we're at this point. I mean, right now, I know I'm talking to you, Stewart. I'm pretty sure that I'm talking to you, but this is one of the final conversations during which I can be pretty sure that I'm talking to you. $150 and 3 minutes of video, something like that, and we can now simulate a person in 3D. Okay. Wow, that's just weird. This is where it's getting some weird times. I mean, when I read Stand on Zanzibar, I mean, this is a book from the 70s or whatever, John Brunner, right? It was because I was naive, it was a machine gun. It was like a music video. Oh shit, this is intense. Well, Alvin Toffler, Future Shock, all that, everything is intense now. It's all like this. And as long as you just lift your head and look around, it's like, holy crap, my brain is not evolved to deal with all of this, but it's great. So the palm trees and the ecosystems and the collapses and the social structures that are kind of all crunching, this is a point of opportunity where we can change the story and evolve it into something more interesting.
Are you at all fussed about what's going to happen with the artificial intelligence stuff?
Well, yeah. I mean, this maybe this is the end of the line for proto-human, you know, the basic model. And I was always like, okay, look, my brain just isn't capable of dealing with the universe as it is, right? I've spent I don't know if it's hours, but a long time looking at hypercubes. You know, you're looking at this 2D version of a 3D thing that's supposed to be a representation of a 4D cube, and you're trying to think of it and understand it, and you're going, okay, up but not north. Like, okay, I'm trying to get it, and you can't. I can't. So I was like, well, what if I, what if I could upgrade a little bit of my brain, right? And get this. Well, yeah, okay. And we're not I'm a pattern, I'm a story. I mean, you can take all the pieces of me, put it in a blender, and you don't have me anymore. And at the same time, I eat food, I'm a wave in food, right? The pieces of you change, but you stay the same, more or less. But of course, you learn my name and suddenly you've changed. Your pattern has changed slightly. And so, okay, if I upgrade myself somehow to understand 4D, I've changed a little bit, but where's the limit between upgrading me and just being something else? So that's one side of the thing where, we've got this merger, and then you've got this fear of, the FOMO of the AIs have left, and they're then I read a ton of sci-fi, and they often the AIs will just kind of go off on their own and like, well, thanks for all the fish and see you later. So maybe, I mean, for the moment, they're just tools, and tools are dangerous and interesting, and we can use them one way or another. But at some point, if we get to the point of intelligence, well, that's another ball game, and it's interesting. But I have changed my position recently, and I don't think I can be so reductionist to think that I'm only the pattern. Because I used to think I was just the pattern. Now I'm like, well, maybe there's more to it than that, because everything is complicated. So, so that's a very long way of saying I don't have a clue, but I'm not worried, because what? I mean,
yeah. So you change from what? From everything, I am a pattern, to what? Or is it unknown?
Okay, hold on.
Still to be decided.
It's a Plato thing, maybe Aristotle. I'm the wisest man alive because I don't know shit. Paraphrasing. But the point is, I don't know nothing, and it turns out that the reality we experience is so constructed and so small. You tap your foot on the floor, you see it and you hear it and you feel it, but the sight and the sound, and especially the feeling, did not arrive at the same time in your brain. The feeling is really slow, and so you have a piece of you reconstructing this and putting it all together because they happened at the same time. And so that's nice, but you're living in a dream world. Cool. Kind of weird. And so I do believe that there's a correlation between my experience and what's outside, but I also believe I have no idea what's outside.
Yes. No, we just a little bit of a brain with sitting in this a little bathtub inside, juggling around in the skull with connections to senses. And I think a really good way of fine-tuning those senses is suddenly start living in the African savannah where there's lions and fucking predators that'll come after you,
That's a way to sharpen it, but it still only sharpens the bits that are useful, the ones that we evolved to see lions. I still can't see radio waves, although they're exactly the same thing as light waves. I mean, they are the same thing, but I can't see them, and they're going through me right now. And, I see this tiny sliver of reality, and this is only the reality that I understand. So, you want to get all metaphysical and stuff, and we're all, just bumps in a common field, and, me and you are the same thing, really, and, all of that stuff. And then there's look at this. I just did this. Well, how did I do this? I get the electricity and the chemicals and the nerves, but still.
But look at it. It's amazing.
This moment. No, but how did I choose? There's a terrible, it's not terrible. It's an okay book, Mind Time. It was the series of studies, okay, about consciousness and time perception and a whole bunch of stuff. But the point is, it's terrible because, not because the author, just because it's a horrible subject. He was trying to study consciousness, and the only way to do that is self-reporting. Well, you can't understand anything from self-reporting. The person you're talking to here, this thing that says I, it's a part of me, but it isn't me. I mean, it isn't the whole thing, right? There's a choir, there's a community of mine. I'm Paul's sister there, Moatib, right? Everything is going on, and there's a whole bunch of stuff. And I read this book. What was it? Everything is Fucked, a book about hope. It was pretty entertaining, and he kind of crystallized something that I really enjoyed, that I had felt. This narrator, the thing that's talking to you and that says I, is interesting, but when you look at split brain experiments and stuff like that, it confabulates. It tells any kind of story to explain itself. Okay, but do
you mean the concept of I just breaks apart when you have a split brain?
If you break up the corpus callosum, the bridge between the two parts of the brain, okay, and then you shunt images to one part and the other, okay, you will tell the brain, you know, they've done tons of experiments, you can look it up, but they say, draw what you saw. And so you draw with one hand and tell me what you saw. And so you sent different images to those two halves. And then one half will say a horse. Okay, but why did you draw a flower? And then the I part will tell you some bullshit story about why it drew a horse. Okay? And this is just a whole bunch. It's interesting when we're nicely integrated, it kind of works out, but it's still an indicator that this is mostly bullshit. So this thing that we've been talking for an hour or whatever, this thing is interesting and it's logical and it has all these things, but it's got the map, it can figure out some things, but it ain't driving. What's driving is something else, something deeper. And so I've always had this awareness that this part is there, and I give it free rein in certain departments. Anything that's not logic, you know, who do you find attractive? Well, you tell me, man, because I don't know, but you know. All right. Okay. So, but that's fine. But it really applies to a whole bunch of stuff. And because it is voiceless in the literal sense, those parts you can kind of communicate, but they're mysterious and weird and deep. And they're just the tip of the iceberg of the weirdness of the reality. And so I don't know what I am is the short version of this long title.
Yeah. Well, I suppose it wouldn't be the reptilian brain, right? Because I mean, that's all that's
breathing and all the balance stuff and whatever. Yeah, sure. But no, it's I think it's more specialized, you know. We Tourette's syndrome, right?
Yes.
I was fascinated when I, thought of that. I was like, wait a minute, that means there's a part of brain for swearing. Okay, that's interesting. And what I think it was in the Man Who Mistook His Wife for a Hat or whatever, that book there. Good book. But the point is, there was this guy, I can't remember if it was in there, had Tourette's, and he was medicating, and he was a drummer, and he realized he was using that in his the improv stuff was powered by his Tourette's.
Oh, shit.
I did this abnormal psych class, and I was reading when I was in college, and I'm reading this stuff, and I'm like, you're reading the DSM, and you're like, oh no, I'm this. Oh no, I'm this. No, you're half the pages, man. Of course. Of course. It's all about, is it interfering with your life? You're a mix of weird shit, right? And so you're a mix of weird shit.
Oh yeah.
Anyways, getting a little off topic.
Yeah, we've gotten way off topic there. I'm not sure where we can pull it back to. Yeah, that was fascinating. It was a fascinating tangent you went on.
Yeah, everything
What?
is.
Yeah. What sort of other areas of study do you work on? I mean, are you doing any academic stuff? Are you doing any like what sort of what's your latest hack project then? How about that?
Okay, hold on. It's weird because I keep coming back to this. At some point, I was asking myself, "Hey, what am I doing? I'm selling my time, right? And that's
Mm-hmm.
fun, and it pays the rent. But what am I trying to do?" And so here's another, magical universe thing. I go, wait, I like research. I want to do some R&D, and coincidence, but that's how I ended up working on the electroactive polymer thing, and it came from out of the blue. But hey, some R&D, all right. And but whatever, I kind of went back into you fall into these ruts. I lived 2 years in California. I had a pool, and I never dipped my toe in the damn thing. I mean, something was definitely wrong with me at the period at that time. I was focused. I'm doing the Silicon Valley thing, but the point is, I easily fall back into, regular stuff. So I do want to do R&D. Now the question is, what do you want to look at? And that's a tough one for me because I have varied interests. Let's put it that way. So what's the future? I develop a ton of stuff. I'm facing problem X, and then to solve problem X, sub problem Y shows up, and I solve that. And so I end up making some tool or something like that. And then often I'll put it online, I'll put it on YouTube, or I'll release some open source project or something like that. But on one hand, it's not useful if no one knows about it. It's here, you can use it. Yeah, but no one knows. So I've been looking at how to get the message out about different things. So that's kind of one area of focus is, okay, you've got some good stuff and you want to share it. How do you actually get to the people who need it? So that's one. Two is I've been thinking about, I've put out some stuff, but mostly software because it's easy.
It's easy,
Here's
yeah.
go away. Cool. But there's lots of stuff I've made, for RF and other things that are physical tools. And I can't, there's a barrier there to sharing that kind of stuff. So maybe that's one thing I've been thinking about looking at. And so those are kind of minutia, but still where I'm looking. And then there's the ASIC stuff. The tools make it really easy. I mean, it's insane. But some of it is still rough. And I mean, I've got, what is it? I'm getting into this guy.
Wait, let's read that. So physical design from graph partitioning to time closure. Jesus Christ.
Yeah. So this is basically what the backend stuff does for me, right? This is taking my design, my logical description, and making it into hardware. So Yosis and pals, Open Lane, do this, but I want to know how, and maybe I can help. So I would like to do that.
I see. Okay.
So
actually, you would like to work on maybe these tools that actually.
I always end up working on tools. In my pay the rent job, I do products. They become things that people sell or whatever they do. I make a prototype run of 20 or 100 or whatever, and then I'm done. I mean, go to Shenzhen. But I'm not a big fab. I don't want to be. But in the end, every time I decide to share something, it's for makers. It's for people who make the stuff. Because if I hit a bump and then divert and spend time on this, well, okay, it's done. But then this wheel's been invented. If I can liberate it, then all of those other people can not think about this and make other stuff and give us more.
Yeah, that would be very interesting. I'll have a word with Sebastian. I know he's looking for somebody to work on
well, you hit all the keywords here. You're talking about cutting edge. You hit all the keywords. You're talking about cutting edge. You're talking about open source. You're talking about all these things that are
ion
hitting
traps.
all my interests. So yeah, the physics part of it. I mean, whoa. I think we need to talk.
Yeah. I know, but yeah, I mean, yeah. How about compilers? Are you into compilers?
Not so much. Okay. I kind of looked and played a little bit, and then I was like, problem solved. Not by me. That's fine.
Yeah. Well, actually, let's take that conversation to that domain now. But I think we should probably we can wrap up the general conversation now, and then we can take the rest offline, if you know what I mean. Yeah, regarding this sort of stuff, that'll be good. Well, Pat, thanks so much for this conversation. I really appreciate it, man. So I'll just say.
It was really fun. Thanks for reaching out. I mean, you talked about having a conversation, a simulated version of having a conversation around a beer. I think this kind of had the right feeling for it, because we talked shop, but also went into space there a few times.
We did. I had the beer. You had the cold coffee, though.
yeah. Felt the same somehow.
All right. Well, let me just stop recording now.